see. Okay, good stuff. Can everybody see my screen? Can everybody see my screen?
Yeah.
Yeah.
Okay, so today we're going to start. As I said, we have many things to go over, right? So I'm going to start from from the cool chop line. And cool chop line, I mean binary search. We'll come back to trees and some of the techniques we need to know when doing trees questions. But I want us to start with binary search and then, to warm our appetite and, so on and so forth, right? Were people able to go through the binary search materials and solve the binary search questions? Could people do that?
Yes.
Okay. Those who couldn't do, that's all I can say. Okay, so binary search is just a way of searching through things, right? And I know most of us here are already familiar with the regular search, which we also went through some when we're discussing, the previous data structures like arrays or lists, dictionaries and all these things. We looked at all these things, right? How they do the searching. And particularly, people remember when we did this, when we learned about in, right? Like for maybe n in num, like if n in nums, right? We all remember how this was. Like, let's assume nums is a list, right? We all remember how we went through this thing, right? That if it's a list, what Python does is that if this is nums, which is like a list or an array, let's say 1, 2, 3, 4, 5, 6, 7, right? Like we all remember how what Python would do was that it will come and let's say assume n is let's say 8. Python can be like 1, are you 8? No. Be like 2, are you 8? No. 3, are you 8? No. 4, are you 8? No. It will do the same thing until it finds 8, right? And that's what we call linear search, right? So linear search, we just start from here, right? And we just be checking. We're checking, are you this, 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 are you that, right? That's what linear search is, right? And so can someone tell me the time complexity of linear search? I know if you woke up from bed, I answer this, you could answer. But somebody
O
please,
of O of n.
good, it's O of n, right? Are we all convinced what n is, right? What is n?
The number of items in the list or the
Good,
number
right?
of
The length of nums, right?
yeah.
Basically, yeah. And that's what we call linear search, which is an amazing technique, right? It's amazing because it could be worse, right? But O of n is so huge, right? What O of n means is this. So those who don't know what O of n, it means that, if we have, let's consider its efforts. Let's call it efforts, right? Let's call it efforts. Let's call effort here, right? And then let's call the length of nums. So when we say O of n, it simply means linear search, right? Which means that if length of nums increases by, so let's say 1, 1, this, and that's that, right? So if this is 1, let's assume they are in chunks of 1, right? For now, assume they're in chunks of 1. My hand ends up writing on the thing. I think there used to be a feature to, let's continue. Okay, right, 2, 2, 3, 3, right? All linear search simply means is that if x, right, that is, if the length increases by 1, the effort will also increase by 1. For now, assume it's 1, right? So that means that if 1 goes by 1, so if this guy goes by 1, goes here by 1, right, then it will come up by 1. So if you go horizontal by 1, you come up by 1. If you go horizontal by 1 again, you come up by 1, right? So that's basically what is happening for linear search. So the graph is something like a straight line, which means that if you increase the length by 1 or by k, you also increase the effort by k. That's what we call linear search. But it gets a bit more trickier than that. What it also means is that sometimes you may increase the horizontal, that's the length, by k, and then you get the vertical, that is the effort, being increased by say 8k, or let's call it jk, right? Where j is some constant, right? So what I mean is this: people know that kind of competition where people slap each other, right? Like somebody slaps you, then you also slap them back. Sometimes you see this guy with tiny hands, like me, and they will slap you with, let's say, 2 energy. Then this other Budo guy who come and he will slap him again, then it will be 8. Right? Like basically every effort that he slaps, that guy comes and it's like giving him like 16, 4 times that double. That is still linear search, right? Because then it becomes something like, y is equal to mx, right? Where x is the length of the nums, and that y there is the effort you're putting in. So it's called linear search. This m can be 1, can be 2, can be 3, can be 4. Does that make sense to everyone? All linear search simply looks like on a graph. Does that make sense to everyone?
Yeah.
Yeah.
Okay. And if you bring to this question, that makes sense, right? Because if the array was longer, right, that is, if we increase the length of nums on the horizontal, that means you're also going to increase the number of effort. You have to check, are you 8? Are you this? Are you this? Are you this? Well, somebody can be like, well, what if the 8 you're looking for is at the start of the array? Then good case, right? We just found it, then we will stop. But the thing is, we can't guarantee that, right? It's a list of arrays. We can't guarantee it, right? It could be here, it could be in the middle, it could be at the end. Usually, in certain complexities, we usually consider the worst case, right? In some cases, we consider something we call the average case. But usually, people use the worst case for the analysis. The best case is if you just don't do much work, right? And we just ignore that. The next thing also about linear search is that you see we have y is equal to mx plus t here. Sometimes, right, it's actually a bit more than that. For instance, when you're searching for the thing, let's say the thing is that if n is in nums, let's say increase n by 2, increase n by 2. But that the actual section is O of n. But when you find n, like when you find the 8, what it is that you increment it by 2, right? And that's an operation you do like once. Number of times you do that operation is bounded. It's just once. You do that operation like one time. So we can add a plus k here. So this plus k, it's simply some constant number of operations that you usually do, right? It could be like maybe just multiply it by something, maybe just double it, maybe just do something. That's what the plus k here. That's why sometimes some of you are like, it is 3n plus maybe 5 or something. You're like, oh, just draw the constant, right? It's because this constant is like you always do 5 amounts of work, right? Like no matter what. Like when you find 8, you only just increment it by 2, which is just one amount of work done, right? Let's call it 1 joules amount of work that you do, right? Basically. Okay, that was just a detour on linear search. Let's jump back to our beloved binary search. So you realize that linear search is actually not the best of things, right? Means that if let's use the case where it is just y is equal to x, right? In other words, when the length increases by 1, we increase the effort by 1, which means that if there are 100 items in our list, we have to do 100 amounts of work, 100 amounts of work. Now, somebody will be like, oh, that's not that bad because computer is powerful. But imagine if there's 1 million amount of items, right? They have to do 1 million amount of work. And it gets worse than that, right? If people remember the find node in a linked list where cycle occurs, sometimes even after you have found the item, the algorithm doesn't end there. You now have to do some extra operation inside, right? Which, and that makes it even much worse, right? So people are like, can we do better, right? Can we do better? And that's when we come to binary search, right? But there are a few caveats. I think I said it like a year or two ago, or like 18 years ago, to two around here, that the thing about binary search, I know some of you know about binary search already, but we usually want to get a question, right? Where the input is already sorted, where input is already sorted, input is already sorted. It is almost always the case that we don't expect you to do linear, right? It's almost always the case that linear is not what is expected of you. This is because sorting this array or sorting your input is already an expensive operation, right? If we do sorting algorithms, realize that sorting algorithms are an expensive operation. Whatever sort to do, whether it's merge sort or whatever. Usually, even the best sorting algorithms, on average, we have some that take O of n, but sometimes, on average, it's n log n, right? Which is quite expensive. It's more, n log n is worse than just n, than O of n, right? So sorting algorithms are quite expensive, which means that if you get a question and the input array is already sorted, it tells you that they've already invested a lot of effort in giving this question. That means that your search algorithm should probably be better, right? Should probably be something that is binary search related. Does that make sense to everyone? Let's tell you some of the things to look out for when you get some of these questions, right? If you get a question and it's already like sorted, and you're supposed to search through something, you usually consider something that is binary search related, which is better than the average O of n. Makes sense to everyone. Can we go on?
Yeah.
Yes.
Okay, good. So that is one thing about binary search. The binary search works on the iterable when the input is sorted, right? The input has to be sorted. Input has to be sorted. So keep this thing in mind. It's so powerful, and I'll show you 2 ways where the input is sorted. One is easy to see. The other is not easy to see. And so we're going to focus our energy on those 2 things, right? So let's take our standard binary search algorithms. There are lots of ways people write this algorithm, but we are going to. What is connected? Sorry, I don't know what this guy does, but I want to get that red highlight thing. Sorry, give me 1 second. Geometry, not geometry. I don't know what's happening. It's okay, let's go. Scribble, 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 scribble. Okay, it's fine. Let's go. Okay. So let's look at how the binary search algorithm works, right? Let's say we have. I beg those of you who know it, still bear with us. We jump from here right on to the code, okay? So let's look at how our binary search algorithm works. So someone give me the list of prime numbers starting from 2. Somebody starts prime numbers. Let's go.
2,
Prime
3,
2,
5,
3, 5,
7,
7,
11,
11,
13,
13,
17,
17,
19.
19. Okay, good. Hey, brother boy. I see. Okay, good stuff. So let's have binary search. So binary search works using 2 pointers, right? The first one that we initialize, please look at how I'm doing this one. That's how exactly how I'm going to write the code. It's so important. There are people who do it differently. I'll show you that one at the end. I don't advise that unless it's extremely critical. So what I will do is that I will follow it. I'll put the pointers on the numbers themselves, on the elements in the list, right? So I'm going to put the left here, right? I'm going to put the right here. Can we all see it? I'll put the left here and I'll put the right here. Then I'll compute something called the middle, right? Note the input array is sorted. That is the superpower. That's why we can use this. The input array is sorted, right? That's the whole thing. So then we'll compute middle by doing left plus right divided by 2. Those of you thinking of overflows, not buffer overflow, of overflows, we'll tackle that later. So what we do is that we do left plus right divided by 2. I'm using this because of integer division, right? Python, if you just do 1, if you do 5 single slash 2, to give you 2.5. But if you do 5 divided by 2, it's going to give you 2. It's going to round it up. Make sense to everyone? So that's why we are doing this. Okay. So now this left and this right are pointers. That's on the positions. So this is index. Let's use another color. That's my thing. Okay, this is index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, right? So at the start of the iteration, right? Let's call them iterations. So this, we're going to have an iteration table. So this iterations, this is a value of m, right? Okay, so for iteration 1, now let's use black. For iteration 1, m is simply going to be 0 plus 7 divided by 2. What would the answer be? Anyone? 0 plus 7 divided by 2. Somebody help me. Hurry up. We have to jump from this topic very quickly. We have a lot to do today. Anyone?
3.
Right? It's going to be 7 divided by 2, right? That's going to give us 3, right? Again, we're using integer division, right? 3. Then the next thing is that, let's move this here. Give me a second. Okay, then next thing is that, so this is step 1. Step 2, we now check. So let's call our input nums. We now check if nums. So look, we are searching for a target. Oh, sorry, I didn't specify my target here. We are searching for a target 11. We are checking if 11 is inside this thing. We're basically searching for 11, right? That's when it says you search for something, right? So now we check if nums of m is equal to target. It's equal to target. I'm giving the fundamental benefit. If I will twist it a bit, this multi-binary search, but we're starting from here. Let me twist this algorithm. So now we check if our nums is equal to targets, right? So we simply check if 3, this 3, so 3 is m, right? We check if nums of 3. What is nums of 3? Anyone? From our thing. What's nums of 3?
7.
What's nums of 7,
Yeah.
right? It's 7. So now we check if this 7, right? So now m is standing here. So we check if this 7 is equal to our target 11. What is our target? It's 11. Is it equal? It's not, right? Can we all see it's not, right? So why do we find that 11? Why do you think 11 will be if it's not 7? Given that the input array is sorted, will it be on the left or will it be on the right? Anyone? Will it be on the left or will it be on the right? Just look at the thing and tell me.
On the right.
Right.
On the right, right? So which means that because the array is sorted, we can discard everything. Look at what I'm discussing. Look how I'm discarding. Ideally, you discard everything, including what m is standing on. Like you discard everything to this side. Like you don't even need to include what m is standing on again. Look, note, right? Because you've already checked that guy. So you discard everything from behind here, which means that now this becomes your new search space. You're basically dividing and conquering, right? So now what we do is that we move this L pointer to m plus 1. Look, we don't move it to m. We move it to what? M plus 1. Because you don't even need to consider m again for your search space. Does that make sense to everyone? So if this condition is less, right? If your nums of m is less, what we do is that we move L forward, right? It's equal to m plus 1. Else what do we do? Else if it is greater, we move R to m minus 1. And then we are done. Are we good on this? Are we good with how the whole algorithm works?
Yeah.
Yes, let me move on.
Yeah. Cornelius.
Yeah.
I have a question.
Go for it.
So if it's less, you move L to m plus 1. Okay.
Yeah.
But if it's greater, can you move L or you must move R because you
If
can
it
still
if it's
move L
greater,
too.
if it's greater, you don't move L. Because look, if it's greater, now let's assume we are looking for 5. Let's assume 5 is our target, right?
Mhm.
And so this is the 5 we are looking for, right? But then
Mhm.
M is here. So realize that you're currently standing on a bigger number, right? You don't move L because what if it's 2, right? So still maintain L, right?
Okay.
Does that make sense? So let's
Yeah,
assume 2,
yeah.
let's assume 2, sorry, you're looking for, right? So if this is the case, then you want to move your search space to here because any of the numbers here could have been the culprit. Does that make sense to everyone?
Okay. Makes yeah.
So you always move one pointer, right? Standard binary search. Now, the way to also visualize the binary search input is this. That's one thing I do. And it's going to help you when you get to binary search in rotated sorted array is because the input is sorted, I usually visualize my input as something like this, as on a hill. Just imagine your input is like, because it's sorted, right? So which means they're going to get something on average like this, so like 2, like basically this is 2, 3, 4, and that's usually how I visualize mine, which I think really makes sense. So let's assume that we are looking for you're looking for, let's say, 3, right? And you did your M, and your M is, let's say, here on 5, right? Like you just know you have to descend down, right? So your L is here, your R is here, right? Let's assume your M is on 5. Then it just makes the sense that you discard everything from here and just concentrate your search here. Just look at those down here, right? And this is really helpful. You come across cases where the input was sorted and then they just divided it, right? So that becomes a case like this. You see, when you probably did this within a week, like sorted, rotated array or something. And it helps if you do like something like this, then you're like this. I think it's like if I bring this one, it becomes
I have a question.
partition to 2. Yeah, you might go on.
What if the the target you're looking for is not
It's
in
not
the
in.
list and they want you to return the position
So if it's not in the
if you
list,
are to
what's going to happen? If it's not in the list, we'll come to get there next, right? But I want people to understand this case first, why it's in the list. Do you all understand this case why it's in the list? Can we step up?
also another question like this, if is it going to be if target is less than norms of M, or is it norms of M is
Mhm.
less than target?
What do you think? What do you think it to be? Given this page we have, what do you think to be? What do you think? Take your time and look at it.
I'm looking at if norms of M is less than target.
Right? That's what it is, right? If nums of M, because look, nums of M
There's
is
some
this.
people that does if targets less than norms of M. Is it?
Well,
I
it's
don't know
also,
if it's
it's also technically the same thing, right? Like if you do if target is less than nums of M, it's the same as doing if nums of M is greater than target, right? Like you have flipped it, right?
uh,
We get it. So like
uh,
this case is same as this case, right?
it's something. Yeah, yeah. Oh,
So
sorry.
the way to
That's
think about it is usually, you just be like nums of M is where I am. That's my current number. Is the current number I'm at bigger than my target? If it's bigger than my target, then I need to discard everything here and just move here, right? And search for it. Okay. Now, before we do the case where there's no number, I'm going to write a standard binary search algorithm that is based on what we just discussed here. So when you're writing a binary search algorithm, what I would advise is this. Always initialize, I'm writing Python code now, by the way. Always initialize your left to 0. Initialize your right to length of nums -1. It's so dear to my heart, -1. Don't go and do just length of nums because look, if you look at the thing, can you see right is standing on like an actual like position, an actual element? Can we see it here? Can we see it here? People cannot see.
Yeah.
I can see.
Yeah.
Good. Right. I always advise you do that. Like let the pointer stand on actual numbers, right? Then now once this is accomplished, your condition then becomes while left is less than or equal to right. Now, these two positions are place of contention. Many people's binary search algorithms are wrong because of these two positions, right? I'll show you later. Then the rest of the algorithm is just what we know. So you compute your mid, which is left plus right divided by 2. Then you need a condition. If now let's even assign to current. Current is equal to nums of mid. Then if current, if the current is less than the target, mean that two currents I computed are too small. I need to make my search space bigger, right? I need to move left to make it bigger, right? Then left is equal to mid plus 1. Then elif. You can do the equality first, right? You can do the equality first, but I'm just, else if current is bigger than target, move right forward. Else, that means they're the same, right? maybe you want to return the position where it occurs, return M. This is basically your whole code, right? Now look at the alternative. The alternative code is this. What I want to say you should do. People initialize the R to be equal to length of nums, right? People do this. Now, if you do that, this your condition must change. It must be left is less than right. I'm just saying, if you do this, you do this. If you do this, you do that. Does that make sense to everyone? But so one way I put in my head is this. You see, there's a minus here. There's an extra bar here. Bring extra bars here. If you omit that -1, it's like 2 bars. 1 bar, 1 bar. Right? If you omit them from here. Sometimes you have to find ways to put things in your head, right? So, but I advise you do the first one. It's just clean. It's -1, then less than or equals. Does that make sense? So yeah, just look at this part. Look at this part of the code. Don't look at the second part. Are we good to go? And I come to twist this out in different ways. Yeah, any questions?
Yeah, I wanted to know, is it always going to be less than or equal to?
Yeah, if you do this guy, like somebody is going to be less than or equal to. You just do that one, then check your code to see if it works. If it doesn't work, then you tweak it. But like this is a standard algorithm, right? If you do the length of nums as R, right, is going to be less than. And I'll show you why. I'm probably not, there's not, probably going to get to a coding round, right? So what happens if the number is not in, right? So if the number is not in, what will happen is this. I'm just going to tell you, you can visualize it because we don't have much time. So when it's not in, what is going to happen is that length L, as you can see this condition, right? L will go past R, which is an error case, right? The left pointer is supposed to be, the ideal case is that L should always be to the left of R, right? But if it's not in, that means that the search space is going to be empty. The search space is going to be an empty search space if it is not in. I would say prove it to yourself using the Python tutor and visualize because we don't have time. But if it hits this case, if this case gets violated, right, L is going to go beyond R, like this, and that's going to be an error case. And that'll happen in the case where it is not in. And when it is not in, L will be pointing to where it should have also been inserted. But I expect you to have figured this out when we did the coding questions this week. So visualize yourself and see. But let me show you the next thing. So we just looked at a very easy case where you just did this, right? Sometimes this is standard binary search case, by the way. Now let's tweak binary search questions a bit. Sometimes they can tell you find the number, like they can tell you if the number is not in, find the number which is like closest to the number which should have been in, but also less than it, right? So find the number which is less than or equal to target. Like the biggest number, the largest number, the largest number that is closer, that is less than target. Does that make sense? So first you're looking for 8, right? But the array looks something like this: 3, 5, 7, 9. So what would be the answer? What would be the answer? 3, 5, 7, 9.
7.
It will be 7. Can we all see it here? Please, everyone understand this question. I'm going to just tweak this algorithm a bit. Like they're like, oh, if 8 is in, fine, return the index of 8, right? But if it's not in, return the index of the largest number that is less than 8. Does everyone understand the question? Does everyone understand the question?
Yes.
So when you get questions like this, you realize that you care about 2 things. You care about both equals and less than. Can we all see it? You care about if you indeed hits an equals condition or if you hit a less than condition. Comprenez-vous?
Oui, monsieur.
Okay. So for situations like that, what you usually do is that for your results variable, right, be tracking, even though you're hitting the current less than target here, right, still be tracking it, right? Be like, then current is still less than, M, right? In the case where you find it here, then it should return M. But at the end of the while loop, if you never came to this else case, then can you see that current is actually tracking M? It's tracking the number that is closest to it. Does that make sense what I just did?
Can you come again?
Okay, so realize that for this question, we care about 2 operations now. We care about the equality case, which may happen, right? We care about the equality case. Can we all see it?
Yes, you can.
And we also care about the less than case, right?
Mm-hmm.
Okay, so what we're going to do is that, note also that as binary search algorithm proceeds, you are always getting closer. When binary search proceeds, it means that you're getting closer to the target. That's something you should put in mind. As you continue the algorithm, always getting closer to the target, right? So now, if we care about the equality case, that is a simple case, which we already know. That is simply else if current is equal to targets, right? But we may never get to this case if the number is not in, right? So then what we do is that for the less than case, we just track this thing here. We just track those positions which are less than target. We always track them. right? And I told this as the algorithm continues, it's always getting closer to the number. Whereas as the algorithm ends, the latest, M that you saw in this less than case is the closest that is to target. Does that make sense to everyone? Right? So you track that variable here. You track that variable here. If the question was that find the smallest number that is greater than or equal to, then we would have brought that case under here. Does that make sense to everyone? Does this make sense?
Yeah.
Yes, it does.
So do
Okay.
you still need to, for the other case, the first one, if current is less than or equal to target, you track it by using current is equals to M.
Yeah.
And
You
then
track
for the else if, the other condition, do you still need to
how do
track
you
it as well?
return? No, you just return. Because
Okay.
because the good case is that I find you. If I find you, hooray, then I can just return, right? But then if after this while loop has ended, I never returned here, I never found it here, then I can just return current. Does that make sense? Technically,
Yeah.
you could track current is equal to M here and continue the while loop, but it doesn't make sense, right? Because you found it, just return it, right? Or you can maybe put a break statement here, right? And then come and return current here. Does that make sense? Like the good
Yeah.
case is if you found it, right? But hey, if the while loop and then you never found it, then current would have been pointing on the smallest, one that was closest to it, then you just return it. Does that make sense to everyone?
Okay. Yeah.
Okay.
So
Let me
if it
step up.
was
Go on.
for the other case, if they are saying you should return the largest one, which is greater than 8. For example, if you're looking for 9, then
So
we'll
the
track
largest, so basically the smallest largest number, right? The smallest largest number is what you're looking for. Please, I want you to understand this part very carefully. When I come to step up our binary search algorithms, and we're going to apply the same approach, right? So what are you saying is, so what we just did right now is the largest number. The first thing we just did, the largest number, that is smaller. It's like two opposing things in one question. That is smaller than target. Please understand this thing. What is smaller than target? Everybody, let this sink in. There are two parts of it. The largest number. It's so important. We come to do another or then binary search algorithm. That is definitely like relies on this. Largest number, that is smaller than target. Does that make sense? So if my target is 7, somebody, what's the answer? What's the answer? The largest number that is smaller than target. What is it? Largest number that is smaller than target.
Yes, 7.
7.
It's 7. Everybody understands? If you don't understand, let me know. Okay, now everyone put this one in the chat. Now I want the smallest number that is larger than target, and target is again 7. What's the answer? Put it in the chat. The smallest number that is larger than target. The smallest number that is larger than target. I want to see answers in chat.
You said the target is 7?
Yeah, target is still 7.
I think
The smallest number that
The
is larger.
target was 8.
the target was 8.
But I'm changing it. I'm just changing
Oh,
it.
Okay.
Using a target of 7. The smallest number. These are inputs, by the way.
Oh, okay.
I need to make sure people understand this part. It's very important, right? So I hope you understand these two sentences. There's like two different things, but in the same thing, right? Okay, can we step up our game now? Okay, so you realize that the binary search we have looked at is a very clean, clear binary search. We've looked at like 3 different versions now. The straight away binary search, less than or equal to, greater than or equal to. But you realize something, that this binary search we are given like an input array, like an iterable. That is so clear to us. It's so easy. We're like, we can literally see the input array, the input list, right? It's easily peasily, right? It's sorting everything. Sometimes some questions are not so clear to use binary search, but if you think just a little bit, like tiny little bit, which is much easier if you're eating rice ball, but like if you just think that's tiny little bit, it becomes clear to you that it's binary search. Let me give you this question. So now, let's assume some of you have solved this question before, but let me also give it to you again. Or you have solved a similar one before. Now, let's assume, are we ready for this next question? Are we ready for it?
Yeah.
Okay, let's go. We come to just give a version of Coco eating bananas. That's what some people call it. Now, look at this. Look at this. So let's assume now we have
Easily peasily.
yeah. Okay, let's assume we have this. Everybody, look at my diagram. I was really good in creative arts in school. In class 4, I used to draw Power Rangers and Ben 10.
The good old days.
Yeah, and when I got older, they told me to draw digestive systems. I don't know why, but if I look back, I should have continued my Ben 10 and Power Rangers.
You draw fish and
Yeah.
lizards.
Rockfish and cockroach, internals of the cockroach. Charlie, time there. God help us. Okay. Okay, can we all see this beautiful diagram? So how many items are here? 1, 2, 3, 4. Please, there are 4 items here, right? Let's write 4. How many items are here? 1, 2, 3, 4, 5, 6, 6. How many items are here? 3. How many items are here? 3 again.
3.
How many items are here? Uno, dos, tres,
Right.
cuatro, cinco, 6, 7, 8, 9, 9, right? Okay, can we all see the setup here? I will focus on the setup. Can we all see the setup here? This
Yeah.
setup here. Okay. Now, please follow the setup so well, like, be absorbed into it. Now, let's assume this setup is, how many, bricks. So, I want to write nicely. So, let's use blue, green, red, black. Okay. So, these are all bricks. All these are bricks, right? So, these are all bricks. Every one of these is bricks, right? And then you have these bricks in, like, containers, right? Or like they're just positioned there like this for you, right? And then we're just simply saying that you have to, hit these bricks against your head, right? So hit bricks against your head. People have that competition against head, right? So number 1, these are bricks. So these are 4 bricks, 6 bricks, 3 bricks, 3, and 9 bricks. Then you have to hit the bricks against your head, right? Now you have K days, right? You have K days to do this. K days to hit the bricks against your head, right? I mean, involving the person very easily to make it understandable to people. So there are bricks. We want you to hit the bricks against your head. And when you hit them, your head is metal, they crack, right? And then K days that you have to hit the bricks against your head, right? Now, on every particular day, right, there's a particular, so these are like, sorry, give me a second. Okay, so these are the bricks you have to hit against your head, right? And now, like you're a human, right? There's a limit to how many bricks you can actually hit against your head, right? If you hit, let's say, 20 bricks against your head will not die, your head will not crack, right? If you hit, let's say, 10 bricks against your head, maybe if you hit 20, let's say you die, right? You're probably going to coma. But if you hit maybe 5 bricks, let's assume like you will not, like die, right? Or maybe not even die, like your head will not crack or anything like that. Does that make sense to everyone? So basically, you have a limit to like your strength, right? You can hit like 1 brick and then you be like coup chop, right? But you can also hit like, like 100 bricks. That will not kill you, but it will maybe give you like a fracture in your head, or maybe something bad may happen, right? Maybe you'll not be able to continue the rest of the journey, right? Does that thing make sense? That thing about your energy, your capacity, does it make sense to everyone? Like you
Yeah.
can do like a certain number and you'll be fine. You can also do like a bigger number and you may be in trouble, right? Does that make sense to everyone?
Yeah.
Please, does it make sense to everyone? What I just explained. Okay.
Yes,
Yes.
yes.
So let's call that capacity. My capacity. Okay. Now the next trick is this. The next trick also is this: that each time you come, right? Each time you come, right? You can only work on 1 bucket. Let's call these buckets, right? So these are all these bricks are in buckets. So let's call this bucket 1, right? Bucket 1, bucket 2. Let's call it B2. And let's call it BKT2. Bucket 3, BKT3, BKT4, and BKT5. Okay, BKT5. Okay, we're almost there. Bear with me, BKT5, right? Okay, so now each day you come, right, you can only choose 1 bucket and do your job. You can only choose 1 bucket and do your job. So if either you come, you can only choose 1 bucket. So if you come today and you choose bucket 2, right, you can only hit some number of bricks from bucket 2. You can't do bucket 2 and go to bucket 3. No. Each day you come. So each day, choose 1 bucket. Right? Choose 1 bucket. Choose 1 bucket. Choose 1 bucket. Right? And then my last thing is there's only, right? So let's make these, let's make it N days instead of K. N days. And then the last thing is that you have to, we are come to borrow that statement here. That statement here, a similar one of it. Okay. So you want the largest, follow me carefully, largest number of stones. We call them bricks, right? Largest number of bricks you can smash, like Hawk smash. You can smash in a day. Look, largest number of bricks you can smash in a day. Look at the second part. So we have the largest point here. To minimize how many days? Please follow me. The question is very easy. I'll go over it again if it doesn't make sense to you yet. To minimize how many days you use in all. So to minimize how many days you use in all.
Optimization.
Yeah, without dying or cracking your head. Let's do it without spilling your blood in a house. Without spilling your blood. Okay. So does the question make sense, or should we go over it again? Does the question make sense?
Go over, please.
Mhm.
Yeah.
Should we go over it again?
Yeah, one more time.
Yeah.
Okay. So we are saying that.
Yeah.
So we have a certain. You have some competition, right? And we tell you these are the rules of the competition. So we have 5 buckets, right? And every bucket contains a number of bricks that is in, right? Now, on every particular day, let's say the thing is happening in, let's say, 20 days, 30 days, 50 days, but forget about that for now. So you come and you choose a certain bucket, right? And then you have to smash some bricks from that bucket against your head, right? So if you choose bucket 1, you have to smash, a certain number of bricks against your head. Now, if you choose that number as this, you'll be like, every day I'll smash 4 against my head, right? That means that every day that's what you're going to smash. Every day that's what you're going to smash, right? So you choose this one, but so let's say you said I'll smash. Let's say, let me write it here. Let's say you said I'll smash 4 against my head, right? So that means that when you come day 1, you take 4, you smash, right? When day 1, bucket 1 is not done. That means when you come day 2 again, you have to go to bucket 1 again and smash 4. Then day 3, you come to let me just write it here. Let's choose the number you choose to be, let's say 3 instead of 4. Let's choose 3. So look at how the question is evolving, right? So let's say days here, right? And let's say buckets, right? Bucket here. And we're going to now compute. So on day 1, it came day 1. So you said, as for you always choose to smash 3 buckets. You've seen that as a straight that you not die, right? Now, if you smash more than 3, blood will spill into my house, which you don't want, right? So you said you choose 3. So on day 1, somebody choose a bucket. What bucket do you choose? You have to do all of the buckets. So choose any bucket you want. Anybody?
Bucket 3.
So you choose bucket 3. Can we all see it here? It's choosing bucket 3. No, you do all the buckets. So whichever you choose doesn't matter, right? When you start. Does that make sense?
Yeah.
Okay. So you chose bucket 3, right? So we chose bucket 3. So we chose bucket 3, and then so bucket 3, we can only smash 3. So then you'll be done with bucket 3, right? Because you can smash all that 3 on day 1. Are we good? So remaining is 0. So you have using 1 day so far. Then it came again day 2. Somebody choose a bucket. Choose a bucket. Choose a bucket. Day 4, bucket 4. So that's what you did. So you choose bucket 4, right? So that one, so how many can you that one is also you can smash all the 3, right? And then you are done. Remainder is 0. So you're done. Okay, now you choose another bucket. Somebody choose another bucket. Please help us with this exercise to make the question stick to your head, right? So the next one you came, you choose.
Excuse me, how is bucket 4 like 3 minus 3? And remember is 0. It's meant to
Yeah,
be
bucket 4
Okay,
contains 3. Yeah, they contain 3 bricks. So you can and every time your limit, your strength, your capacity, which we defined here. This your capacity is what we defined here. Capacity is how many you can do without dying, right? The maximum amount you can do without dying, right? So you came and you're like, okay, me, I can do 3. I can smash 3 bricks against my head and nothing will happen to me, right? Okay. So you chose bucket 3. You came, just did all the 3. You went to bed. The following day, you came again. You chose bucket 4, which also has 3 bricks. You smashed it and then you went to bed. Does that make sense? So that's where we are now. So somebody choose the next bucket you want to face. What's the next bucket? Again, you do all the buckets. So it doesn't matter which one you choose next, right?
Bucket 1.
You choose bucket 1. Somebody follow us. So bucket 1 has how many?
4 bricks.
4. But how many can you smash?
3.
3.
3. How many will be left?
1.
1. Okay. So now you come to 4. Where will you go to again?
Bucket 1.
Let's make it life easy. Let's go bucket 1 again, right? Then now you can, there's only 1 bucket. You can smash past of 3. But again, on a day, you can only choose 1 bucket. So that's like, yeah, I'll just smash that one and go my way, right? Does that make sense to everyone?
Mhm.
Yeah.
Be 0 now. So then we can go and sleep, come the following day, right? What bucket will you choose?
Bucket
So this
2.
5. You come bucket 2. What do? You
Smash.
smash 3, right? Does that make sense to everyone? We smash
Mhm.
3. Please follow and try to contribute. Make the things stick to your head. So now you then have 3 left, right? The 6, you come for that bucket 2 again. Then the remaining 3, you smash all 3, right? Now left with 0, right? Now what will you do again? What bucket is left? It's left
Bucket
5,
5.
right?
5.
We have buckets 5 now. So that's day 7. Day 7 is bucket 5, right? So bucket 5 has how many? 9, right? So you do 9 minus 3. Now you have 6 left, right? Then on the 8, you choose bucket 5 again. Then that is also 6 minus 3. Then there's 3 left. Then the 9, you choose bucket 5 again, right? Then that's also 3 minus 3. Hooray, you are done. Can we all see what we just did? Can we all see this exercise we just did?
Yes.
Yeah.
The exercise makes sense to everyone.
Yes.
Mhm.
Okay, good. Now my next question then becomes, how many days did you take? Follow me on. We're like, how many days did you take to finish your exercise? How many days did you take to finish the exercise?
9 days.
9 days.
9 days.
9 days, right? 9 days. And I'm like, is this the best you can do? Like, it's a competition. If it took less days, we'll give you the award, right? Is this the best you can do? Then they'll be like, I did 3, but when I realized that I could have done maybe 5, I could have done maybe, 6 buckets. I could have done maybe 6 bricks per day. You realize that if you could do 6 bricks per day, can people see you are taking less days? Can people identify that? If
Yeah.
you did 6 bricks per day,
Yes.
right? If you did 6 bricks per day, you realize that, like this guy, like for bucket 1, we could have done bucket 1 in 1 day. We didn't need 2 days for bucket 1. In the same way, we didn't need, is it bucket 2 also, right? Like if we could do 6 per day, we could have used just 1 day for bucket 2. Can everybody see this?
Yes.
Please follow the story. That's literally the question we are discussing right now. Like once I'm done with this, can literally write the code. Does this make sense to everyone? Like at first you choose 3 bricks, but every day you just do 3, right? But that's going to take you 9 days. So capacity of 3, capacity of 3, you use 9 days. But then we're like, if you could do capacity of 6, looks like you use 7 days, right? Or something like that, right? Then you're like, actually, maybe I'll just do 1 capacity. 1 capacity, can you see 1 capacity will take you many more days? Can everybody see it? Capacity of 1. Let's assume every day you just do 1 break. Can you see it will take you like a lot of days? Take you like 20 days or something. Can we all see that?
Yeah.
Okay.
Take the sum of all the days.
Yeah, exactly.
Oh.
If you do 1 break, you take the sum of all the buckets, right?
Yeah.
The bricks in the buckets, right? Now, does this make sense? Does this make sense to everyone? Before we go on to solving the question, does this make sense to everyone?
Yeah, it does.
Yes.
Yeah.
Are we sure this makes sense? Because that's basically like the whole thing. Now, if you look at this, there were some rules we set, right? What are some of the rules we set? One rule we set was that, like, every day you can only go to 1 bucket, right? Like, so whether you chose 4 and you came and there was 1 break there, you can only do that 1 bucket. Do that 1 and go and sleep, right? Do you remember we had that rule?
Yeah.
Like, you can't handle more than 2 buckets, so on and so forth. Okay. So now, given this, we are like, well, we want people to, have some notion that there's a restriction. So the next thing we are going to do is that we're going to give you a number of days you cannot exceed. Look at it. They're going to give you a number of days you cannot exceed. But if you don't give people number of days, and like it's a competition, you have to give you a number of days you can go to. We say you should use. If you go beyond this number of days, sorry, you have lost. You are guaranteed to have lost, right? So the last condition is that there's a certain number of days, right? I even had it here. 10 days. That is like you don't go across you don't go beyond this number of days. If you go beyond this number of days, we are sorry, but you're out of the competition. Does that make sense to everyone? That is basically the question. So then the question then becomes, now this is the question we are solving now. What is this capacity? What value should we use for this capacity? What is this K? Like, what is this? What is the ideal number of bricks you can smash? Like, what is the ideal number of bricks you can smash to minimize? That's what we have here. The largest number of bricks you can smash to minimize how many days you can actually use. When you don't, and make sure you don't go beyond K. Does that make sense to everyone? The question we come to solve. Like,
Yeah.
as number of bricks I can smash to make sure that I minimize my number of days, right? To minimize that. Now I want everybody to take a couple of seconds and think about this. And by the way, it's a binary search question, right? It's a binary search question. But I want to take your time, understand this question, and then we move on. Once that's settled in you, once you have soaked in it, send a yes or something to the chat so that we know how many people have soaked in it. Then we continue. Hey, no yes, no emoji reaction, nothing.
We are soaking.
Hey, me, I need to see at least 1 yes in the chat too. Make sure people are here with me.
We are still consuming.
Yeah, we
Oh,
are
yeah,
not
still consuming.
soaking.
Take your time.
Yeah.
Take your time. Take your time. Like, try and understand it first. Like, take your time. Make it soak in, right? Like, soak in it. Are people consuming it? Please make sure you're paying attention. Those of you with short attention span, like after 30 seconds, you try to do something else. Please don't do that. Like I tell people like whenever you're solving these questions and things, you don't just understand the solution, you have to understand the question. If you understand this question so well right now, right, you'll be able to apply it to other questions, right? I've met at least 2 questions that use this logic, at least 2. One is actually one skyscraper question. Like you use a similar analogy like this, right? Where like you have to do something, but it's like if you're able to like maximize it, it decreases how many days it takes you, right? Or how many, So basically the analogy of this question is this: like you can maximize a certain quantity, right? Maximize a certain quantity and then decrease how many days it takes you, right? So imagine you're pulling things from, let's say you work, like you let's say you carry cement, right? From, let's say the mom has asked you to maybe carry cement from house A to house B, right? You know that if you carry it, let's say $5 a day, let's say there are 20 cement, if you carry $5 a day, it's going to take you maybe 4 days. But if you carry just 1 bag a day and you're on lease, it's going to take you 20 days, right? So you want to find that sweet spot where you can maximize. Also, you don't want to die. You don't want to go and try and carry 20 cement bags, right? You die, right? You want to find that sweet spot where you can maximize how many cement you can carry, but it will still be fine. Does that make sense to everyone? That's literally what you're trying to do. Does that make sense to everyone?
Yeah.
Yeah, so get that logic in your mind. It's going to help you know it when you get questions like this, right? It makes it easy for you to identify the pattern. Are we good? Are we good? Understand this question because I'm going to give you a question that is based on this thing. And I'm going to need you to analyze it and convince yourself that this is similar to what we just discussed. See me low, see me low, see me low, 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 see me low, see me low. Are we good? I've not seen a yes in the chat. That means people are still consuming. Go ahead. Consume. Okay, are we good to go? Hey, sorry, my device says you cannot mind me, so give me a second. It's connected. Okay.
Yeah, come over.
Are we good to go? So even if you didn't understand this one, use the second analogy I gave, right? The one said carry cement from house A to house B. And then like there are 20 bags of cement there. You know that if you do 1 bag a day, they're going to take 20 days, right? But if you also decide to do 20 bags one day, like, as we want to finish right now, and you do 20 bags, like on just one day, you probably die, right? Like your back, your spine, everything will collapse, right? So you want to find that sweet spot. Like if I do 5 bags a day, that's sufficient, right? I'll still be fine. It will take me 4 days. Maybe mom says, don't take more than 5 days. So that is N days there. Mom says, don't take more than 5 days. You're able to finish it in 4 days, you're good, right? You're so good, right? And so on and so forth. Okay, let me go on to a coding question that uses this algorithm, like this similar.
Yeah.
Okay, yeah, Eugene, thank you. You have saved the people. Yes, Eugene said yes. Okay, then let's go. Now I'm going to show you a question. Take off time, because we have to jump onto trees again. Hey, my thing is not minding me. Okay. Give me a second. I'm trying to share my screen. So I'm trying to share my screen. What is the Zoom thing? Oh, yeah, it is. Yeah, it is. Yeah, it is. Okay, screens. Am I able to see my screen?
Yeah.
Oh, people can see my screen. By the way, we are trying to get a new phone. We're debating between the S24 Ultra, but who uses an S24 Ultra here, by the way?
Buffer.
Or it's an S25 Ultra. Wait, Buffer, is it true?
Yeah.
Which one do you use? S25, S25?
Cornelius, don't mind them. I'm here using my Nokia 3310, trying to navigate the.
Not lie.
I see.
Yeah,
Yeah,
Cornelius.
I'm to get a new phone. My current phone is so old and very bad, and it hurts my eyes. but it's like many. It's like
Cornelius, I can take over your current phone when you get a new one.
yeah, okay. Right when after you bring the $200 for just the screen, then 400 for the rest.
Refurbished.
Yeah, okay. Let's see this question. So yeah, I've been debating for the past 2 days which one to get. I don't want to get an iPhone. I feel like there's nothing new in the iPhone. So
You get a
Pixel.
Pixel.
what, Google Pixel?
Mhm.
Yeah.
I look at
Cornelius,
the
you need to get
I look at it.
We
an
can get
iPhone.
to why
Well,
You can wait for the
it's
17.
Yeah, I'm waiting trying for the 17. I'm like, would there be anything different though? These iPhone Pro. I used my friend's iPhone for a couple of minutes and like I didn't feel different. But the S24, the S25, they're like literally like powerhouses. They feel good. My friend had one at corner when I used to hold it. Like you feel like you hold it, you're like, I'm elevated. Like,
Take
but
care of
iPhones are like,
it.
I think I just use iPhones. I want to try something new. Or the Pixel 9, which is like, but the conclusion, the moral of the lesson is this: we are contributing funds. I'll be sending the GoFundMe links after this. So if I still take Momo. Like, let's contribute to the cause. Yeah. So now I'm able to look at this question. Some people are scared of leak code, so let's copy it away from leak code and go and paste it in our Python tutor. Some people love this guy more. So I'll help you. Don't worry. Hey, we needed to expand the whole thing. Don't worry, I'll break it down for you. I want you to look at this question. I wish I could have them side by side. But you all understood that first one we looked at, right? I want you to, basically look at this question and see if, try and understand this question, and then, okay, can everybody see the question?
Yes.
Okay, let me maximize it a bit more. For those who have 80-year-old people's eye, when you're just 24. Okay, please read this question. Like, let it sink in. Like, take your time, read the question. Like, yeah. You cannot read English, I can read for you. Okay, everybody can read English. Okay, please read the question. I'm giving like a minute or two. Make it sink in. It may be confusing, but read it. I'll simplify the question, but just read it. Like, try your best, right? Okay, like try your best, your maximum best to understand the question. Take your time. To do it, let me try to see if I can. I want to highlight the important information. Is there a place I can do that? On Slack. Okay, after that, we use Slack to do something. Okay, sorry, can I change screen quickly? I want to highlight what I think is important for people to focus on. Can I do that real quick?
Okay.
Yeah, I feel like everything is going to make, like, some people may not be like, okay, let's put something here. Let's put it here. Okay, can everybody see my Slack screen?
Yeah.
Okay. Give me just 1 second. Bananas per hour eating speed simply means that this thing has to be that on a day, how many bricks can you smash against your head, right? Don't let this thing like trick you, right? It simply means how many bags of cement can you carry per day, right? Here they're using hours, right? But we're using days. Does that make sense?
Oh, yeah, makes sense. Makes
Yeah,
sense.
that's what it means. Yeah, that's what I want to highlight those things.
So, okay.
Yeah. So let me just highlight this so that people, because I feel like sometimes some people they see too many words, they get thrown off. So each hour simply means our time each day, right? You choose a certain cement, a certain bucket, and then can smash that one against your head, right?
So the each hours is the constraint. You have to finish
Yeah.
everything within.
And if the pile has less than K days, you eat all of them. If you remember, when you choose a bucket, there's only one brick in, and your capacity is 3, you still do like,
Let's finish it.
yeah. So you need that information too. you eat all of them, right? And you cannot, right? You will not eat anymore. At the end, I'd have highlighted everything.
I tell you.
You need to eat all the bananas. Remember, we said like you'll be doing.
Within each hours.
Yeah. Okay, so now let me make this bigger. Oh, this thing too is like, I just want to. Is this clear? Is it like I want to just focus on the relevant data? Sorry. Is there no way to place this? Is this clear enough, like to know what to focus on?
Yes.
Yeah. Okay. Let's try this now. Okay. Please, everybody, try and master the question. Okay, are we good to go?
Yes.
Yeah.
Okay, everybody, are we good to go? Because we're not going to go into the coding. Are we good? Can we start? But I want everybody to understand the question, though. We all understand the question, right?
Yes, we do.
Is there anyone still processing the question? Anyone still processing it? Hey, everybody's done. Hey, I beg you. Okay, let's continue. Very smart people. Okay. So can you all see the Python tutor place now? I'll come to trim. So when I read a coding interview question like this, right? I trim down the information. Coco loves eat bananas. Coco is a monkey. Just time I said Coco is a monkey. Or Coco is criminal. I also love bananas. Then there are n piles of banana, right? So n piles, right? So piles, maybe just give yourself something else. Like can just be like
And buckets.
yeah, Intuit doesn't care, right? So I'm going to edit this question, right? Like, n buckets, like, rewrite the question the way you want it. So like so one way to also do that is as like some of you already know, if you have a question, like can just filter out the relevant information. That's what I do. Like, because sometimes just be like there are n buckets, right? Or you get n piles, whichever works for you, right? Like, and then the ith pile has piles I banana. This is nothing. It may sound like unfriendly, but like it's nothing they have here, right? It simply means if you look at the input, it's like like A, B, C, D, right? So like a pile simply refers to an index, right? That's what they mean here. So like let's use what numbers? 1, let's say 3, let's say 4, let's say 2. What am I doing today? Let's say 9, right? So they mean that let's say it means that piles of I, so piles of 0 simply means that there's one bucket. So that's what they mean, right? That the number of bananas in a pile is simply piles index. That's thing. Does that make sense to everyone? Like, I mean, it's nothing scary. Does that make sense to everyone? This part. Does it make sense?
Yeah.
Yes.
Yeah, okay. It's
I
not
was thinking
uh-huh.
for the ith pile has piles I bananas. I was thinking like when they say fifth pile. So the fifth pile has like 5,
Pile index 5.
5 bananas, right? Oh, that's
Yeah,
not
that's
the
what they
case.
mean. Yeah, they
Okay.
simply mean that. So if I mean like if I say the second pile, so if I ask you how many bananas does the second pile have? It's just piles index 1, right? That's just what they mean, right? Like
Okay.
nothing scary, right? So I'm just going to remove this. I'm just trimming it down. The gas have gone and will come back in 8 hours, right? So that's like the limit you have, right? So your mom told you, don't take more than 5 days, right? Or the competition people told you, Like, because if they don't set a restriction, you'll be like, I'll just do one per day, right? Like, you'd be like, man, I'll carry 1 bag of cement per day, right? And like, you take so many days, you never finish, right? So this is just a restriction. Does that make sense to everyone?
Yeah.
Does that make sense to everyone? Okay, so we have our restriction here, right? So like, or it just be like max. Like, this is the max number of hours you can take, right? So max hours. Like, you can't go beyond this, then you're in trouble, right? Each hours. Hey, does this make sense to everyone? Comprenez-vous, tout le monde? Okay, I'll answer for you. Then Coco can decide her bananas per hour eating. That's like how many bananas Coco can eat per hour, right? That is K, right? So capacity, right? What Coco can do. Or let's just call it strength, right? Strength is right. K bananas, right? That is like every hour, Coco can eat K bananas. Does that make sense to everyone? Right? You can be like per hour. Right? You can eat K bananas. Does that make sense, everyone? And this information, feel free to write out. If you get this person in a coding interview, feel free to write this out. It's fine, right? Okay, let's proceed. So we are here. So we are basically done with this. We're done with this. And then each hour, you choose a certain pile, right? So each hour, you choose a certain bucket. Then you can eat K from that pile. So if you choose a pile and it has exactly K, you eat everything. If it has less than K, you eat everything and reserve the rest of your energy, right? If it has more than K, then you eat and then you leave the rest and come the following hour. Does that make sense to everyone?
Yeah.
Okay, so just be like 1. So you can just choose 1 bucket per hour, right? 1 bucket per hour. You cannot do more than 1. 1 bucket per hour, then you eat only K, right? Like eat only K, right? So you can be like eat at most K, right? But if there's K, of course you eat it, right? So I just be like, if interview, just like eat only K, right? You cannot eat more than K, right? Okay. Then so we are basically done with like this. So see, the question is just being simplified. You like to eat slowly. Yeah. Everybody's lazy. If they ask you to carry the cement, you'll be like, I'll carry this 1 bag of cement every day. Or the brick, like, I just hit 1 brick every day, right? That's like Coco. Coco is also lazy, right? Everybody wants to finish everything. But then you have to finish everything, right? Like, no matter how lazy you are, we don't care. You still have to do the whole job, right? Does that make sense to everyone? Like, you still have to pour the bags of cement. You still have to, smash every brick, right? So you may be lazy, but you still have to finish the job. We don't care how lazy you are. You enter the competition. You have to still, finish everything. But then you're like, okay, given your laziness and our restriction, wants you to find a sweet spot. And that is what the person is asking you. That return the minimum integer K. And what is K? The strength, right? That will also fulfill our restriction. That is a minimum integer K, right? That you can eat all the money. That's our restriction within 8 hours. Does that make sense to everyone? So once you give us K, how many bananas you can eat such that you actually indeed eat all the bananas, but you also don't exceed the number of maximum hours we are giving you. Does that make sense to everyone?
Yeah.
That makes sense to everyone. So that there are like 3 things to look out for here, right? There's minimum integer K. You have to do all the bananas, and you have to do at most 8 hours. You cannot go beyond 8 hours. Does that make sense to everyone? If you want me to write it out, number 1, we want minimum K, right? Such that you can eat, number 2, all the bananas, right? And then number 3, less than 8 hours. One way to also think about it is this.
Less than or equal to?
Oh, less than or equal to. One way you can also think about it is also this. Let's assume, as for Coco, let's flip it around. Let's assume Coco is not a lazy person. This is banana. Break, you could be like, you're lazy, so you do 1 every day, right? But let's say banana is sweet, right? Coco be like, oh, then me, I'll eat 100, I can eat 100 bananas every day. Coco is, let's say, very hungry person, right? Then we're like, we don't want you to eat 100 every day. That one, you probably finish everything in 2 days, right? We still want you to still lower your appetite, bring it down, right? Like, give it a smaller number. That's how I'm saying makes sense right now.
Yeah.
I've told like 2 different questions. There's one question where you try to, find the maximum you can do. The next question is where you can find the minimum you can do, right? Who can be like, oh, for me, I can eat 100 bananas every hour. You're like, nah, we don't eat 100 bananas every hour, right? Like, calm down, please, I beg. Regulate your strength, right? Eat maybe 5 or 7, right? But still make sure all these constraints are satisfied. Does that make sense to everyone? But that's the question we're going to solve. Want you to minimize, so let's assume you come with a very big capacity. They want you to minimize that your capacity and still satisfy these last 2 conditions. Does that make sense to everyone?
Yeah.
Please, the rest of it doesn't make sense to you.
Yeah.
Okay. So this is a binary search question, as we said, and we're going to start, sake of time, we're going to go walk through the solution I wrote some time ago, and then move on to the next thing. I've actually discussed two different questions with you with this one. There's actually two different questions I've discussed, but let's focus on one. I feel like if you understand this one, you can easily figure out the other one. So let's look at something here. So can we all see there? Are people comfortable with the word piles? We want me to rename it to buckets. Is piles
This is okay. Yeah.
Okay, I almost renamed it. Okay, sure. Piles is fine. Okay. So then look what we are going to do here. So what are we trying to find? What are we trying to find? Can someone remind me? What are we trying to find?
The minimum.
The minimum strength, right? You came and tell us you can eat 100 bananas every hour, but we want you to give us the minimum you can actually eat, right? And still satisfy these two conditions. Does that make sense to everyone? The minimum and still satisfy these two conditions, right? There's another question where you can tell us to do the maximum you can do and satisfy. You want the minimum you can do, right? Okay, the minimum you can do. The minimum you can do again. And you remember the thing I discussed last time, that if you cannot do it exactly, once the minimum, you make your change in the less than or equal to. But I'll come back to it again. Okay, so let's start. So we know what capacity you can find. So then you realize that you can start to be like, I'll do 1, or I'll do 2, or I'll do 3, or I'll do 4, or I'll do 5, or I'll do 6. Can you see the numbers I'm mentioning already sorted? Can you see there's already a certain notion of sorted order here? Can everybody see it?
Yeah.
Can be like, I can do 1 strength. Be like, 1 is like, can you do like, okay, I'll be like, I can do 100. Be like, 100 is too big. I can do 80. So can you see there's a notion of sorting here? It's a notion of sorted order. There's the range of your strength is actually in a sorted order. Can we see it here? That the range of it is in a sorted order.
Yes.
Can you identify that? So can you see here, unlike the first binary search thing we did, where we are given an input array, like that was so clear to you, right? But here, there's still a notion of sorted order here. It's actually implied that the strength you can actually, your capacity, your eating capacity is in a sorted order. It can be 1, it can be 2, it can be 3, it can be 4. But when that sweet spot, right? That sweet spot, that will still make this condition hold. Does that make sense to everyone? So we're going to do a binary search on the strength. The binary search on the strength. But note, the strength we gave you is just an integer. It's K. So you're finding it's actually K, right? Like the strength you're looking for is some number K. It's an integer K. But then it can be like K, it's a spectrum. It can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It's like from 1 to some bigger number. We want to find that sweet spot that will still make all these conditions hold. Does that make sense to everyone?
Yeah.
Or I should repeat? Okay, makes sense. So this is what we're going to do. We're going to be like, so the strength of let's take this example here. Take this example here. So this example here, please follow me. You're just going to walk through this. This example here, we already established that the strength is already in a certain sorted order, right? The strength is in a sorted order. So for this particular example, right, the strength is how many you can eat per hour. So the minimum I can eat per hour is 1. Can we all see it? It's 1. That's the minimum, right? And what is the maximum you can eat? Like I can eat infinity, or let's say you can eat like, let's say 100, right? So this can be your strength. Your strength, I'm creating a certain list, a certain notion of a sorted order for you. So the strength can be like 1 to 100. That is maybe your strength. Does that make sense to everyone? This could be your strength. So I'm basically going to do a binary search on this, your strength, and find that sweet spot, maybe somewhere in the middle here, right? That will still make these two conditions hold. That you eat all the bananas, and if you use the strength, the total number of hours you take is still less than or equal to H. Does that make sense to everyone?
Yes.
Does that make sense to everyone, please? Who is getting confused? Who is confused? Who is confused?
So in a question like this, is it possible that you can have more than one?
More than one what?
Or that sweet spot is like the only, like,
Hey,
if you can have more than one answer.
if you can have more than one what?
Answer.
One answer.
Oh, more than one answer. Not really. It's only going to be one answer, right? It's going to be a number, right? It's going to be one number. But it also means I can eat 4 bananas, and then I'll still satisfy the two conditions, right? So you're going to find that strength you choose, that capacity you can choose, and still satisfy.
Cornelius, quick question.
Go for it.
So, what criteria did you use to like end it at 100? If you go back to the lead code, or is it Python to here? You know,
Like,
you went from 1 to 100.
I'm just, it could be anything. It could be the 1 to infinity, right? Right.
Okay.
It could be like anything. It could be like 1 Like you can be like, my strength is I can only eat one banana, right? Or you can eat any number, like now I'm just using the number 100, right?
That's
It could be
it.
like,
Okay.
it could be like any max, right? Because it can be like 1 to any number you can eat, right? But the thing
The
is,
range.
we know you can do any number, right? So let's say 100.
Infinity.
100. What's the answer? What would the answer be? How many days will it take?
Wait,
And
I'm trying to understand.
4
Like
hours.
this,
let's
Colin,
for
is this 3, 6, 7, 11? What does it represent? Like
house
in
of
the sense,
bananas. Like so, like you
I
have
know it's spice. I'm trying to understand what it represents. Like, is it each banana or
each bucket has 3 bananas. The
oh
first
each packet?
no, the
Oh,
first
packet 3, packet 6, packet 7, packet 11.
yeah, but it's like the first bucket has 3 bananas. The second bucket has 6 bananas. The third bucket has 7 bananas. The fourth bucket has 11 bananas, right?
How's it
And
called
at
bananas?
each point, right, you can only eat. So let's assume your strength K is 100. That means that when you come in the first hour on day 1, if you choose the first bucket, you can eat at most 100 from it, right? Day 2 or hour 2, you can, if you choose the second bucket, you can only eat 6. They can eat at most 100, but this is 6. That means you can finish everything, right? So let me ask this. If K is 100, how many days will it take? How many days?
4 days.
Yeah, 4 days.
Oh, do we all agree?
Yeah.
Okay. If the strength is let's understand these things, right? I could have solved this question like 5 minutes, but I'm trying to break everything down to clear people's confusions. But once you really understand the question, whenever you see a question like that, or which uses this approach, it's easy for you to come up with, right? So let's do let's do strength versus days graph here. Okay, if I have 100, how many days will it take?
4.
It will take 4. Do you agree? If you don't agree, let us know. Okay. We're using this same example. Okay. If I have, say, 50, how many days will it take me?
Still
4.
4.
It'll take me 4, right? Is everybody following? If I have 25, how many days will it take?
4.
4.
4.
Now, you can see that all the days we have got is still less than H. H here is 8. That is, they have given you 8 days, right? 8 days. That means that 4 days will be wasted. But, like, why? So but the thing is that we want you to still minimize this thing and still make you less than or equal to. If you look at the condition is we need it to be less than or equal to H, right? So that's like I'm still going to decrease my strength so far as I don't go beyond H, right? Like we want you to minimize that your strength so far as you don't go beyond this H. Does that make sense? It's like an optimization problem, right? Like, what's the question? Like, realize that we are still like at 4. 4 is still less than 8. So let's still see if we can do better. Does that make sense to everyone? How we are still going down? Realize that we have to do binary search kind of thing, right? Like, so yeah, this is what we got. This is our current value, right? And it's 4. But 4 is still less than our target, which is 8. Can we see it? Can you see I'm solving the question here? Right?
Yeah.
Yes.
Now let's do 15. Let's say 15. That is our current value. How many days will it take?
4.
It's 4.
Nah, our current is still less than our target. So can we do better? Let's go down. Can we do 10? If we do 10, how many days will it take?
5.
It will take anybody. Everybody put in chat. If I
5.
eat 10 bananas, how many will it take? Everybody put your answer in chat.
Yeah, 5.
It will take 5, right? I hope you
Yeah.
agree. Take 5.
Yeah.
Because you take 1 day for the first bucket, 1 day for the next bucket, 1 day for the next bucket, but the last bucket will take 2 days. It will take 2 hours. Does that make sense?
Yeah.
But see, 5 is still, our current is still less than H, right? It's still less than 8. So should we decrease our strength further? Yeah, we can.
Yeah.
It'll be fine, right? Let's assume we decrease our strength to 7. How many days will it take?
Still 5.
5, right?
Yeah.
5. Yeah.
2 days for the last bucket. Does it make sense to everyone?
Yeah.
Okay. Then we are not done though, because we are still like less than 8, right? We can still do better. We can still decrease our strength and still do better. I mean, we don't know. That's what binary search is for, right? We are still searching for that sweet spot, right? We are like, let's say I'll eat 5. Let's assume I'll eat 5 per day. Then how many days will it take me?
7, 8.
How many will it
Take
take?
you 5.
No, it will take you more than 5 though. Because if you eat 5, you take 2 days for this. You take 2
Yes.
days. You take 2 days for this. It'll take you 7, right? I think it'll take you 7,
Oh, 7 days.
right?
Yes.
I think we take 3 days for the last one, the 11, right?
Oh yes, it will take you 3 days for you,
Yeah.
right? Right? Because if you can eat 5 bananas, the first day you can eat all 5. You can eat all 3, right? This one, you need 2 days for that. So we have 3 days now, right? This one, you need 2 days for that, right? Can people say we are computing the 2 days? Simply divide, just do floor division, right? Like 6 divided by 5, right? Sorry, mod. I think mod will even do.
Yeah.
Hey, no.
Not to take the
Remember.
Still.
I mean, simply just divide the number, right? It's like
Yeah.
5 times something. Okay. Then 11. How many days will it take if you can eat 5? How many? It's taking 3, right?
Yeah.
3, yes.
You first do 5, then the 6 left, you just do 1. Okay. So, but are we still there? We are still like on that sweet spot, right?
Mhm.
So like still 8. We're like, I've made the 8, but can I still do better? But can I step down and do 4? If I do 4, how many days will it take? Anyone? It still take 8. It still take the same 8, right?
Mhm.
Yeah.
Do you agree?
Yeah.
Because
Yes.
if you can get everything on 1 day, right? How many days will it take the second bucket?
2.
2 days, right? So we are 3 days now. What about this one?
2.
Two.
So
2, right? We are 5 days now. What about this one?
1,
3.
Days.
3,
That's like 8 days. So we are still on that sweet spot.
1,
But you see, our
2,
strength has been lowered,
3.
but we satisfied our condition. Can people see what we are doing?
Yeah.
Now let's be like, let's be chisel. Let's step down a bit. 3 days. How many days will it take? 3 days. How many days will it
This is 1 day, 2.
take? How many? It take
10
like
days.
days,
Yeah.
right? You will
Yes,
see,
10
it take like
days.
10 days. You're like,
10 days.
we've exceeded our condition. We have violated the condition. Once we have violated our condition, we needed at most 8. But now we are taking 10 days. The moment you violate it, binary search, you're like, stop. I'm done. What was the last guy I saw? That was 4, and 4 is my answer. That's literally the algorithm we're coming to do. That's the whole solution to this question. We just
So you just have to be decreasing -1.
not necessarily actually. You see, it looks like -1. But you see, when we're doing the top part, we were taking huge leaps. Here we decreased by like half. We slashed, right? Like we
I understand the thing. Binary search on that 100, 50, 20. Oh,
right? I did it this way so that to make it make sense, right? But from there, we could have done always divide by 2, always divide by 2, always divide by 2. Like we could have done always divide by 2. Then this one take us maybe 20 days. Then we'll be like, let's go up. We'll be like, let's go up, let's go down. So we get to that sweet spot, right? That's the solution. So you can see that we were actually trying to find the number of days, right? That's what we were trying to find. So at the start, look here, do we need to actually start from 100? Not really. We just start from, let your maximum strength be the maximum number here, the maximum number of bananas in the bucket. Because look, it will be the same thing, right? If I start from 11, it will be the same thing, right? It will take me the same 4 days. Can we all see it here?
Yes.
Binary search, I want let the minimum number of days be 1, and the maximum number of days be the max of piles. Again, it can be 100, it can be anything. And then let's make it so that my binary search finishes early, right? Like, right? So I realize that all these ones, like the 100, 50, 25, they never changed. So still I got that to that 10 that something changed. Can you all make sense? So I want to make the maximum I can eat the max of piles, right? Does that make sense to everyone? These 2 lines. Minimum is 1, then the max would be like the maximum, the biggest number of bananas that's any bucket holds, right? Then now you're looking for that sweet spot. Find the middle number, right? So if it's 1 to 100, choose 50, right? Then this code you have here is simply this calculation you're doing here. So this code, let's look at this code here. Everybody understands this code, right? And this code here, right? This is right? But it's like, I'm finding some K. Now here, after you choose the K, you have to check how many, the total number of days, given this K, you used to complete every single bucket. And that's what we did here, right? If you remember, we are like, oh, if I can eat 10 bananas, let me see. It would be 4, let's do it. If I can eat 4 bananas, you came to check how many number of days. You're like, okay, here, 4, it will be 1 day here, then 2 days here, then 2 days here, then what, 3 days here. Do you remember that calculation we did?
Yeah.
We're computing how many number of days to take to finish everything. That's what this loop is doing. After you have chosen that to K, well, I comment here, right? That means basically okay. The number, your strength, you check. Given this strength, what are the total number of days I can take to eat everything? Like, so you take every pile, check how many days it will take you to consume everything. That's the code for that. Then now you check that's your number of days here. You're like, is that number of days bigger, lesser, or equal to the limit I have been given? Right? So you're like, if it is less than or equal to, I'm going to track it. Realize that when it's equal to, we don't stop, because we still want to minimize it. And that's the thing I showed you at the start. But sometimes you put the condition in your less than or equal to. So then we track it. If it's less than or equal to, right? Then we track it this way. Then we're like, it's less than equal to, but can I still do better, right? Can I still do better, right? And if it's bigger than, like, can I still do better? That's basically what we are doing here, right? Does that make sense to everyone? That's the binary search part of it. Does this make sense?
Yes.
Okay. Everybody take some time and look at the code. The code may make 100% perfect sense to you, but that is why, the YouTube videos, like, which we sent you and everything, just watch the video, and now everything makes so much sense to you. But I'm giving you a minute. Look at this code. It may not make sense, but
So can you explain line 30 again?
which one? Line 30.
Line 30,
30 is simply saying, now you have chosen, you're like, I'll eat 5 bananas every day, right? 5 bananas. That's what you said you choose, right? But we need to make sure that if you said you eat 5 bananas, how many days will it take you to eat everything, right? So then you take every pile, every bucket. Like, so if I can eat 5 a day, how many days will it take to eat the first one? You're like, 1 day. The next one, how many days will it take you? How many?
2.
2 days.
Yeah, 2 days.
So now you have used 3 days, right? 3 days for the first 2. The next one, how many days will it take you? Another 2. So now you've used 5 days, right? Then, like, so that's what this one is doing.
Okay. Then mass dots. Oh my God.
What math dot seal is like this. If you
Yeah,
have
that mass dot seal is. Can you? Is there any other way you could do that mass dot seal is?
It's very easy. Let's understand. Math dot seal is very simple, right? What it's trying to say is this: 14 divided by 3. Okay, let's do. People like to divide by 5. 17 divided by 5 is what? What's 17 by 5? Let's do regular division. It's going to be 3.4.
Something.
3.4, right?
Yeah.
Something. Exactly. 3 point something, right?
Yeah, 3%.
And then that point something is the remainder that you have to come and eat that remainder, right? Like, you have to come the following day and eat it, right? So then we're like, round it up. So that becomes what? 4. So math.c simply means that, hey, divide it. After you divide, if there's a point something, bump it up by 1, right? Like, just bump it up. Like, find the ceiling of it, right? So the math.ceil, that's the ceiling. Math.ceil of 4.5 would be what? Somebody. What would be the
5.
answer? It would be 5,
5.
right?
But I think there's another way to write this.
Nah, this is like, it's math thing, ceiling and floor. There's another way, but it's complicated, honestly. So I say when you
Yeah,
come
it's
across,
complicated. Yeah, mass dots.
Yeah.
So it's okay. I can learn this.
So the math
Yeah,
seal. So the math seal is different from the rounding up, right? Because this one is more of, you see, if it's 4.5, you round it up to 5. But then this one, no matter what it is, whether it's 4.1,
yeah, as far as it's a point something, like if it's a 0.0, like you're good, it should be 4, right?
Yeah.
But it is 4. It just finds the next integer.
what if it's 4.05?
If it's 4.000000001, it will bump it to 5. So
Yeah.
far you have a surplus, right? It is going to bump it up for you. It's just
Okay.
bump it. Does that make sense?
Yeah.
Yeah. It's in math, it will tell you it's just the next bigger integer after what you have, the next integer after what you have, right? Like, so that's what math.c is doing, because there's a remainder of some little banana there. You have to come following day and eat it, right? That's what this is doing. So you just find the total number of days that you use if you choose this strength, which is your mate, right? That's the key, right? Choose a strength of mate. This number, then you check, is this number of days satisfy my condition, right? So this is making sure you're eating all the bananas, right? So look, there are 2 conditions you have to satisfy. When you choose a key, you have to check, can you eat all the bananas? And if you can, is it less than or equal to H, right? And that's what it's doing here. So this is, you're making sure you're satisfying that first condition. Here you're like, eat all bananas, right? That's eat all, right? That's why we're going through every pile, right? Then here, is it less than? Like, you have to be like, is it less than or equal to H, the total number of hours? Does that make sense to everyone? If it's less than, you track it. It can never be greater. Look, look, let me explain something here. If it's bigger than H, you don't care. You don't even track it, right? But you're okay if it is less than or equal. You care about those 2 conditions. If any of those conditions is met, you track it. You remember I mentioned this thing earlier, that sometimes it may be equal, fine. It may also be less. You track it either ways, right? But if it's bigger, you have violated the condition, right? It has to be less than or equal. That's why we are tracking results in here, right? So if it's, in case we're always taking the minimum, right? Because we want to find the minimum mate, the minimum strength possible, right? Okay. Are we good?
Yes. Makes so much sense.
What's the solution to this one? I hope now it makes sense to you when you go through it. And yeah, Let's take a 1 to 2 minutes break and then we resume.
Okay, makes
Yeah.
sense, makes sense. So
Yeah.
if it's less than equal to, okay.
And actually it's like this. So like and realize that we did a binary search on something that is not like we didn't do on piles. Can you see there's no binary search on the input piles? It's not even sorted, right? Like look, right? We did binary strength on a certain strength, right? On a certain number, right? And that's a notion of binary search I want you to have. So that you actually do binary search on something where and there are many questions like this actually. Let's see if we can find some similar questions. Look, and it's a very important to see, even most of them are like hards and mediums and everything. But you need to know this quick. It's a very popular question, right? Like, let's see, maximum candy. Let's look at this question. If people can read this. We're on a break, by the way. 1 to 2 minutes, I'll teach the next topic. But as you're on the call, still look at this. Look. And see, read it. Someone read it. Everyone read this question and see if you can sense that flavor, that pattern in this question. I'm just giving you time. Read this question. I gave you on break. This is what we're using our break time for, by the way. Read this question. If you can like identify a similar flavor in that. I've not done this question before, but like read it and see.
Mm.
It's actually it's a one-to-one map. I'm not reading. It's a
Yeah.
one, like it's just a bit. Look, let's see how we can map it one-to-one. You can divide each part into any number of tiles. That's like you can basically when you take a certain bucket, you can like you can go into it. It's like you can use any number of days. You can use any number of days to eat the bananas in the bucket. Look, if the bucket contains 10 bananas, right? You can use 10 days to eat it. You can use 5 days to eat it. It all depends on how you decide to, the size of the pile, right? That you want to make it, right? Basically, then the eating capacity, right? If you use an eating capacity of 5, you divide that pile into two, right? Into 2 sub piles, right? Does that make sense? If you choose like if you be like every pile should contain five bananas, then or 5 candies here, that means your pile will have 2, right? Does that make sense to everyone? Like that's basically it. That's a one-to-one mapping, right?
And
you can
some
2 piles together simply means that you cannot eat from 2 buckets, right? Like if you cannot eat 2 buckets. So for instance, let's assume that you are like every pile will contain a max of, let's say you came here like every pile, I'm going to eat 5 per day, right? Which is in here, that's the same as saying that every pile is going to contain a max of 5 candies, right? Then the thing had 12 candies. So you put 5 down, how many is left? 2, right? You cannot go to the next pile and go and borrow 3 from there. Can that make sense? It's actually like just do a little bit of processing too, but it's actually like interesting. I think I'm not sure if let's pick out the solution. Let's take a look at the solution. It's actually like it's literally one-to-one. You may just have to do a little bit of, and that's the question we get in an interview, right? Just have to do like a little like bit of thinking, like, and you'll be there. Let's look at the Python solution. Can you all see it's like the same code, right? Like it's just like this. It's the same thing, right? It's just like look, max. Can you all see we did the max minimum? This find the minimum, and this. Oh, by the way, this solution here is like it's almost like the one we had like our math.c and something like it's the same thing. Then here, but it just like as we do less on the courses, but it's the same thing, right? Like, but I want to have the intuition to see the pattern, right? Once you have the pattern, and it's that when you see the slightest hint, like you are there, right? That's how I want you to learn the question. So learn the question, understand the question. So when you see ones that are related to it, it becomes like, at least you know that binary search can be used for something like this, right? Okay. Are we good to go on to this next topic? We'll be done soon, by the way. Are we good to go?
Yes, good to go. And Cornelius.
Yeah.
Yeah, I mean, after we're done, I wanted to like see if we can talk for like some 2 minutes.
Yeah, I can. Okay, yeah. Recorder, please stop and restart. We're not going to do some